Well, today on the bench, I have this battery control module, this battery protection controller. And if you watch some of my videos, you know that I've used this as a battery load cutout up to 60 volts, so it's pretty handy. So whether you're building something out of, say, Milwaukee 18 volt or you DeWalt 20 volt stuff, up to even like my Ego 56 volt stuff, we can use this to protect the battery just by putting our parameters in to protect the voltage from going too low. I'll try to have a little video up here as we see a few times that I've used these, and I have used, like I said, several of them, and I have several of these, and I do like them. And this one here, for some reason, I powered it up and it actually didn't last long, and the display went out. As I'll show here with 30 volts across it, or 30 volts input rather. Bring over a meter and show you that we're getting our 30 volts. And we're getting our 30 volts in, and there was no reverse polarity or anything done. It was all input from an Ego battery 56 volt. It just it came on and powered up. The relay clicked on a few times and then it just quit working. It was almost brand new. So yeah, I just thought we'd do a little troubleshooting today. If maybe somebody else will find this interesting. The first thing I'm doing is just going to this regulator. This looks like a 117. It's an AMS 1117. So this is supposed to be a 5 volt regulator. And as we can see here, we're not getting any input. We go to pin 1, pin 3, we're not getting anything. So we should be getting our voltage across this little capacitor. And there's our 30 volts, 29 volts there. So let's have a look at this little switching chip, because really, other than the microcontroller, this is really a simple board. The diodes actually look good. This little switcher is a XL Semi XL7015E. So I do have some of these, so I've had to replace a few in the past on some other projects. I'll try to have the data sheet up here, top left corner here, so you can see, just as I'm seeing on my screen here, it's showing my pin 1 being VN. The tab, of course, being ground, as well as pin 3, which is a typical way to do that. So we are definitely getting our input, just as we thought from our cap when we checked it. Pin 5 is going to be our enable pin. And I think low is enable, and it's not high, so feedback, which we're not going to get any right now. And our pin 2 is going to be our switching pin. And pin 2 is not really doing anything. So typically at that point, I'll replace that little switching chip, because I believe the little MOSFET driver is gone. So these are only, I think, 0.8 amps, so it's not a high current switcher, but it does go up to 80 volts, so it's 150 kilohertz, like a lot of the XL Semi switchers. And yeah, up to 80 volt DC to DC switcher. So let's see if we can get that off of there. Let's see if we get lucky. I got a little baggie here of some of the exact XL Semi switchers. So let's see what do they do. So I believe the first thing I want to do is remove this electrolytic cap, because I'm going to have so much heat around it. It won't take but a second to just pop it out of here. So just catch it. I don't think it was solder holding, just caught on the edge there. Now I can put more heat there. And I'm going to put some rosin flux on here to help transfer the heat. as we discussed before, these have the little pad on the back, so it can take a good bit of heat on the tab to get these to release it from time to time. There we go. Definitely don't want to damage any pads. When you hit that tab hard, you know pin 3 is also getting a lot of heat, but we got to make sure our other pins get enough heat. Sometimes, of course, it's easier just to go through and lift up each pin at a time, so you know that you won't mess up a pad there. Still got one stuck here. Of course, my pad's stuck back. Here we go. I'm going to remove this little LED display so we can see a little bit better. I tried to be careful, but of course this cheaper board, those little pads did pull right up. Some of them did anyway, so I'm going to try to save the board by scratching off some solder mask here, maybe it's so thin, and shifting the chip and maybe soldering on. I'll work away at this and we'll be right back. So let's bring over the microscope and we'll look at it a little closer. So back now after cleaning this up, it is not the prettiest. That was definitely tougher than I even thought it was going to be. In part because I got the pads, I guess, a little too warm, and these cheap boards are bad about the pads lifting. So, but after scratching through, I've checked continuity on the voltage in back to my plus where the cap goes. And of course, the tab of the ground's got a good connection there. Back to the negative for the cap. And my switch goes to my little inductor there. And by the way, I don't know if you saw it on video, but my soldering iron hitting that corner, I actually desoldered the wire off of the connection point. So as I was checking my inductor, I was getting K ohms. I believe it's okay. We're gonna find out. But I did have to solder that back on there. You can see that there. Had to solder it back on. So I'm just gonna throw the cap back in it and the display, and we'll give it a shot. Need to switch over to my other tip. Moment of truth. Hey. Yep, that's why I had it set at all right. 29.8 is what I got on my power supply. Cut it down. Going to 15 volts. There we go. Well, it's not pretty, but I like it. So I hope you found this video at least helpful or interesting. If you did, please like, share, subscribe. I'll also have some links in the description if you're interested in these little control modules that are handy for protecting your batteries. I always have other helpful links as well of things that I find helpful on the bench anyway, including the little board holder and the little flexible arms you can add yourself to those, as well as a lot of my desoldering soldering tools. Any of those that you find interesting that you would like to click on does support the channel and is greatly appreciated. So thanks so much for watching, and God bless.